All right. Should we do a couple to make sure we are on the right track? Yes? Okay. So make sure that you notice this is not a graph of f of x. Yeah. Yeah. Sorry, I could have told you that. Notice this is not a graph of f of x, this is a graph of the derivative. So that makes a difference for the problem, okay? So how do we find critical points? They're where the slope equals 0. They're where f of x, or f prime of x equals 0. So critical points, I'm just going to write that real quick. The critical points, oh, thank you for that. I thought I was doing something. Okay, so critical points are where f prime of x equals 0 and where else? Yeah, and where it's undefined. Okay, so if we were to go through and make a sign chart based on this graph, we have negative infinity, we have positive infinity. Where does the derivative equal 0? At 0. Where else does it equal 0? Negative 3. Okay, where else does it equal 0? 4. Okay, so negative 3. So f prime of x equals 0. F prime of x equals 0. F prime of x equals 0. In all of those places. Okay, let's figure out our signs, right? Okay, so to the left of negative 3, is the derivative positive or negative? Positive. How can you tell? Is it because it's going up? It's above the x-axis. Okay, so if it's above the x-axis, the y values are positive here, which means that the sign is positive. From negative 3 to 0 right here, this part of the derivative is below the x-axis. It has negative y values. So the sign chart would be negative there. From 0 to 4, the derivative is below the x-axis. So it's negative there. And then over here, the y values are positive, and so it's positive there. Make sense? Okay, so now we throw away the graph, because the graph at this point is going to distract us, because we're going to want to look at that graph for the answers now, and that graph is wrong because it's the derivative, not the function. Okay, so we throw it away. Okay, now we're going to use the first derivative test. So the first derivative test says that where a function switches from increasing to decreasing is where a relative max is. Where a function switches from decreasing to increasing is where a relative min is. Okay? Does that make sense? Okay? So if you look at your sign chart, how can we see where it switches from increasing to decreasing? How do you see that on a sign chart? Positive to negative. So we can see increasing, decreasing. So where's our relative max? Negative 3. So our conclusion is relative max at x equals negative 3. I don't know what the y coordinate is. I don't have enough information for that. But I do know there's a relative max at negative 3 because I've watched what happens with the derivative. It switches from a positive value to a negative value. Okay, now if I look at the graph of the derivative, that's going to mess with my brain, because does that look like a relative max to you? No, do not look at the graph to do that. You have to think through and interpret what it means, okay? Now there's a point where you'll do this enough times that you'll be able to look at this and go, above is increasing to below is decreasing. You'll be able to do that, But until you have done enough of these to be able to do that, you have to be able to put this graph out of your mind and think through it switched from positive to negative, okay? Because it is not an intuitive thing. It is a learned thing. It's like learning a language, and learning a foreign language is not intuitive when you first do it, okay? All right, now this is from negative to negative. So this is one of those situations we talked about where it's like negative to negative, right? No max, no min, just going down, okay? All right, over here we've got negative decreasing to increasing, so what's happening there? Relative min at x equals 4. So that is the type of thing they are looking for each of these problems, okay? Does that make sense? Okay. All right, what are your critical points for number 2? Okay. So from negative infinity to negative 1, what's the sign? Negative. From negative 1 to 0, what's the sign? From 0 to 3, what's the sign? From 0 to 3? Negative. And then from 3 to infinity, what's the sign? Positive. Okay. Mm-hmm. So what's happening, so I'm going to throw away the graph now because the graph is not going to help me with my intuition. It's going to mess my brain up. I'm going to throw it away. So what's happening at negative 1? Decrease to increase, so there's a relative min at x equals negative 1. Okay. What's happening at 0? Increase to decrease. Okay. What's happening at 3? Decrease to increase. Right? Now, these sign charts that we call them, they are common to be seen on FRQs. They give you no credit. No points, no credit. They're not going to give you positive credit for it. They're not going to give you negative credit for it. They don't get mad when they see it, but they will give you no points for it, okay? Your justification is not a sign chart. This is not calculus that you have done, okay? Our reasoning here, when we say there's a relative min at x equals negative 1 and x equals 3, is we say because f prime of x switched from negative to positive. See how I said f prime of x, not the sign chart? Okay. Or you can say f prime of x went from less than 0 to greater than 0. Notice I didn't say switch signs. That's vague. Switched which sign? Because both of these switch signs. Okay. Notice I didn't say it switch signs. What is it? Notice I didn't say the graph switch signs. The graph of what? Does that make sense? So whenever we're doing calculus for these, we have to be very specific about what we're talking about and what it did. F prime of x. So we say either f of x, f prime of x, f double prime of x. We're very specific to name it. And then we're very specific to say what it did. Switch from negative to positive. Okay? All right, go ahead and do the other ones. When we get to the point that we need to do some more problems together, like if you get to the point where you're starting to work on Larson, let me know. I will stop class and we will do some more together, because it's really important that we understand how this works, because we're going to build on it. And then also, this is a very big idea in calculus. Okay, we're going to be reading and interpreting a function graph, a derivative graph, a second derivative graph, and it's a type of fluency. It's a type of visual math fluency that we need to have. Okay, so I do want to make sure that you guys are comfortable with this stuff. I don't want you guys to be struggling at your tables at all. At any point today, if there's any sort of struggle, we pause, we do it together. Sound good? Okay, we're going to look at number 8. So it says f prime of x is x squared minus 9 times g of x. G of x is less than 0 for all real numbers. So when we go through and we look for our relative maximums and minimums, what do we typically do? Hi. We find our critical numbers first, right? So we want to know where the derivative is 0. I think he maybe wanted to get help and then realized that was not a good time. All right. So we're going to see where f of x equals 0, right? And we're going to do that by setting each of the factors equal to 0. Does that sound good? Okay. So I can factor the x squared minus 9. How do I do that? X minus 3, x plus 3. Okay. And then I got the g of x. So how do I make what's the solution for the first factor? Positive 3. And what about the second factor? Negative 3. And the third factor does not equal 0 because it's less than 0 always. Does that make sense? So I'm going to think of that as maybe like a coefficient of like -5 or something. Like it's just something that's always negative, or maybe it's like a negative e to the x. Like I can't solve it to get anything, but no matter what I plug in, it's going to give me a negative answer. Does that make sense? Okay. So, and then I'm going to say over here, like I've got a negative infinity and a positive infinity. I don't know for sure. Oh, but it does say for all real numbers, so I do know that actually that it goes forever. I guess I can make these zeros instead of endpoints. Okay. All right, so I'm just going to put a little negative up here because I know that that's always going to contribute a negative because it said g of x is less than 0. Are we comfortable with that? Okay, so let's start plugging numbers into our sign chart to figure out what our signs are. So what's a number less than -3? -4. Okay, so if I plug -4 in, -4 minus 3 is a negative. -4 plus 3 is a negative. And negative, negative, negative is negative. Awkward. You were very committed to that too. That was you forgot about this negative, and that's fine. That's fine. Yeah. Okay. What's the number between -3 and +3? 0. All right. 0 minus 3 is 0 plus 3 is. Okay. So if we have a negative times a positive times a negative, positive. Okay. And then what's the number between 3 and infinity? 1, not 1. 4.
You went with it for a second. You were better.
So 4 minus 3 is 1. 4 minus 3 is 1, which is positive. 4 plus 3, positive. So we have a positive times a positive times a negative. There we go. Okay. So if we look at this, what do we have? Same thing. Local or relative is the same thing. Okay. So, based off what we found,
That's it.
which answer? B?
The positive reinforcement is true.
Yeah. See how that works though? Okay. So did we do okay on 5?
Yeah.
We did okay on 5? Sort of. Should we talk through 5? Okay. So, strategy on 5, can we tell, if this is f of x, can we tell where f prime of x equals 0? Where is that? 0, and, oh, so it equals 0 just at 0. And then does not exist here. And does not exist here.
Wait, I'm sorry.
Because they are both cusps. Yeah.
Why? Wait, yeah. Is the F prime of? Why is it that those undefined things are not?
They are. So we got 0, we got -1, we got +1. So from -infinity to -1, what type of slope do we have? From -1 to 0, what kind of slope do we have? From 0 to 1, what kind of slope do we have? From 1 to infinity, what kind of slope do we have? Okay. So now, when we look at the graphs, instead of, we're going to ignore this because this is going to distract us now because we're going to be trying to think of that graph. So now, we're going to say, okay, from -infinity to -1, I'm going to look for a graph of the derivative that is underneath the x-axis, okay? I'm going to be looking for a derivative that has x-intercepts at -1, 0, and +1. -1, 0, and +1, or something of the sort. So can we narrow down what our possible answers could be? Can't be A or C because they had -2 and 0 and +2. So we're going to get rid of A and C. Okay. So now we're going to say, okay, it's got to be underneath the x-axis for -infinity to -1. So how does that help us? It's not D. Okay, because that's positive infinity. Okay. Can't be E. Okay, because that's supposed to be at positive infinity from 1 to, it's supposed to be above the x-axis from 1 to infinity, which leaves us with B. So we can see it is underneath the x-axis, it is above the x-axis, it is underneath the x-axis, it is above the x-axis. We can see it kind of does what we expect. So right here we have an x-intercept, and then at -1 and +1 we have an undefined sort of thing happening, which kind of makes sense. Not necessarily just like this, but something funky, yes. Yeah. Yeah, derivative doesn't exist somehow. Yeah. It might not look like that, but something funky happens there. Yeah. Okay. Anything else we should talk about? Not at the moment. We're doing good. Have we switched over to working on Larson yet? No? Okay. Is the Larson assignment short? It's too long. It's not very long, but it's too long. All right, so it says find the value of C that satisfies the mean value theorem. We do not have to do all the steps of the mean value theorem because this is a multiple choice problem. So remember, the mean value theorem is just to show where the average rate of change and the instantaneous rate of change are the same. Okay, so how do we find our average rate of change on 1, 4? How do we find our average rate of change? Slope. So we're going to find our slope, and we're basically going to do f of 4 minus f of 1 divided by 4 minus 1. Okay? So I'm going to do, yep, average rate of change. So I'm just going to do, I'm going to type this in as 4 sine 4 minus 1 sine 1 divided by 4 minus 1. All right, and then whenever we're doing problems like this is not my final answer, so I'm going to go ahead and store this, and I'm just going to store it as A. Oops.
Wait, what did you say were equally the instantaneous rate of change
To average. Average rate of change is slope. So this is average rate of change. And they're using the word mean as in AKA average. Mean value theorem, AKA average value theorem. Okay, so the average rate of change is approximately negative 1.290 or 2895. All right, and I stored that as A. So the mean value theorem says whatever the average rate of change is, the instantaneous rate of change has to be the same as it somewhere along that curve of the derivative. So what we're going to do is we're going to find the derivative. So f prime of x is, and then this is a product rule, so how do we do the product rule? Okay, so what I'm going to do this with a calculator so my life is easy, is I'm going to graph this as y1 and I'm going to graph this as y2, and I'm just going to see where those two things cross. So I stored my slope, my average rate of change is A, so I'm going to go in here and I'm going to do, there's my y1, I did it backwards, but it's okay, and then my y2, and they told us to do the interval from 1 to 4. Now, I know that sine graphs bounce back and forth between positive 1 and negative 1. This is not just sine, this is x times sine, so I'm going to do a little bit bigger than positive 1 and negative 1. I'll do positive 3 and negative 3 just so I have a little bit of wiggle room there. I'll graph it. There's my negative 1.290, and then there's my curve, and I can see that they cross, and this is my answer here for C. And the reason that they don't look parallel is because I'm looking at the graph of the derivative, I'm not looking at the graph of the function, right? The graph of the function is where I would have seen them looking parallel. So I'm just going to find the intersection, and there's the answer right there, 2.462. Okay, so that's how I found it easily without having to solve it by hand. Now, if this was calculator inactive, that's one where you probably would have been able to evaluate it on the unit circle, and you would have been able to set them equal to each other, and you would have been able to solve for C by hand. We couldn't do it by hand because it was a calculator active question. They made the numbers hard enough to deal with that we had to use a calculator to solve. All right, any questions on that one? Yeah. So for your window, it'll say invalid dimension if you did like 4 to 1, or if you did 3 to negative 3, or if you did the wrong negative sign. If you used a minus instead of doing a little negative sign. If your negative sign looks long instead of short, it'll be that you used the wrong negative sign, but that's when it says invalid dimension, is if your numbers are backwards. Look at your negative, type in negative 3 again, and make sure that you use the negative down here and not the minus. Okay.
Do you have to